Hey everybody, welcome back to episode 3 of Writing the Snake game. In today's episode, we're going to introduce an environment class in which we will do some checks. If the snake goes out of the boundaries, then it will die. Or if the snake goes and eats its own body, then it will also die. So let's see how this goes. So let's introduce the new class. Let's call it environment. And the first check should be if the snake is out of bounds. We need to have an idea what are the actual bounds first, so that we can make a check whether the snake head is out of those bounds. Let's actually make a constructor here. And this constructor should take some corners. Let's see, we can have two corners, the top left corner and the bottom right corner. Or we can have a minimum x, maximum x, minimum y, maximum y. What could be easier? Let's do top left and bottom right corners. If the snake goes out of these bounds, then we should check in this method. So let's see, this method should return a boolean, which is basically the check if head get x lower than, that's one condition, or if the get x of the head is larger than the right. And then do the same for the y, like so. And now let's hook up this environment in the snake game. And we have a hard-coded environment, a hard-coded terminal, which it has 80 columns and 25 rows. So this would be, top position will be 0, 0, and bottom right will be 24, we said, and 80, or actually let's put 79. But what is the last one that we can actually go to? Because the 25th row is not available. We can only go to 24 rows, so the index of the 24 row will be 23. I think that's it. We need to create a method to check the boundary conditions or the collision. Let's do it after we calculate the next state. So in the do loop, we do here check collision. And it needs to be something like if environment is out of bounds, then we need to put in there the snake head. Then basically we just need to print out that the game is over and exit the program. And we make the is running false, so that means we stop the while loop and we exit the screen. Let's run this. Ah, all right, something's not right. Let's see what I did wrong. The position first has an X and then a Y. Ta-da! Let's go down. Boom. Okay, out of bounds, game over. Go to the right. Out of bounds, game over, good. So it seems to be working. and to the left. If it reaches 0, goes beyond 0, out. Good. Perfect. Let's now implement the second condition. If the snake goes onto its own body and it's eating its own body, then we need to end the game. The way I'm thinking about this problem is we have all the positions of the snake, and then the head moves somewhere and it's going over an existing position of the snake, of the body. If that happens, then basically the snake just went over itself and it needs to, it will die. This means we have to be able to check if the head position is somehow entering on any of the positions of the body. So if the body is actually a list, then we need to make a check whether the head of that list is contained in any of the positions of the list. The method should be in check collision, and it should be here. So if environment is out of bounds or snake is eating itself, then the game should be over. So let's create this method. Method is eating itself, boolean. So what we're doing here is first we check if this head is null. So this is the first element in the iteration. That means that is the head. Otherwise, if head is not null, then we check if any of the other elements in the body is equal to head. If it is, then that means the snake has gone over itself. So we return true. Now there's a special case that we need to take care of here. In Java, the equals method over two objects has to be implemented by us. Basically, if we just do equals between two objects like this, by default, it will not work. Because we're comparing positions, we need to override the equals method of the positions class, and then we need to check if the x of one object equals the x of the other object, and y equals the y, and so on. Let's do that. Override method equals. There's also another trick here. If we modify the equals, if we override the equals, we also need to override the hash code, but later on. Right now we don't need it. I think we will need it if we implement a hash map or a hash tree of position elements. So for now, let's just do the equals. Don't need this. So let's see some checks here. The other object we are checking is not a position, so let's first do some checks, some easy checks. If object is null or object is not an instance of position, then return false, because they can't be equal. We are checking the current instance to a null object. Well, an instance can never be equal to a null object. Then let's cast the object, call it other, position object, and now we return if our get x let's see if this works. It compiles. Let's run it. Let's make a loop. Boom! That was easier than I thought. I'm looking at this method here is eating itself, and I'm thinking maybe I can do it a bit nicer. Can I do something with contains? Because basically what I'm trying to detect if is is the head of this list found anywhere else in the list? So maybe I can use the contains element, the contains method on this. So let's see if I have a contains method, which gives me a position, and if that position is not 1, which is not 0 basically, it's not in the top of the list, then it means it's contained twice. Index of, oh, I can do this. I can do a last index of, and if last index of is greater than 0, then it means it exists in the body somewhere and it is not on the first position, so it exists twice then. So that means it has gone over itself, so it will basically die, game over. Let's compile this and run it. Boom, nice. This is a bit more elegant. I like this solution better than just iterating over the list. So I think I'm going to keep this. I'm thinking whether I can enhance this environment class a bit. Maybe I should make the snake part of the environment and then just make the collision checks on the environment itself. Something like this. Private final snake. And we add snake or set snake here. Now we can add it as a parameter in the constructor. And then we can do here, hold on, let's change the constructor. We have a snake, yes, we have created a snake, we set it to grow, create the environment for the snake, add on the position for the boundaries and the snake itself. There's only one snake in the environment, so we can set it when we create the environment object. Then check collision would just call a check collision on the environment. So this could be environment check collision. And if that happens, then game over. So basically replace this two checks and place them into the check collision on the environment. So the environment knows about the snake, so it can check if is out of bounds, the head of the snake, or if the snake itself is eating itself, then is a collision. So basically we are just calling the environment to tell us if there has been a collision, because the environment should be aware, should have a state that there is a collision or not. That's why we put the snake in the environment, and that's why we check for the boundary check and position of the snake relative to itself, whether it is eating itself. I think this looks better. I think I'm going to end this video here for now. This was a nice video to explain a bit the environment and how we do the collision checks. And we saw a couple of nice methods of how do we check the equality of two objects in Java. And we got a nice method for checking the existence of duplicates of elements in a list, basically using the contains and the index of a particular element into a list. So thank you for watching, and as always, if you find this content interesting, please like, subscribe and ring the bell so you get a notification next time I upload a video. Bye for now.